And the last problem type, proofs. I know you've missed them. All right, these are not so bad. I think maybe you have missed them. I don't know. So I'm going to start my proof just like I start all proofs, and I'm going to look at the diagram. I'm going to mark up the diagram. E is the midpoint of BD. That tells me that BE is congruent to ED. I also am given that BCA is congruent to DAC. All right, so a couple different ways to go with this one. What I'm thinking of is I'm thinking of kind of this top and this bottom triangle here. So if I look at this triangle and this triangle, I'm thinking I could prove those two triangles congruent using what method? Well, maybe you see that I have some vertical angles here. So could I use angle side to prove those two triangles congruent? Once I've proven those two triangles congruent, I can go ahead and say their corresponding parts are congruent, and I can go about this in several different ways. So the first part of this proof is I'm going to prove those two triangles congruent. I'll do a flow proof with this one. So I'll start with my first given. E is the midpoint of BD. And remember, what that told us, so I'm going to draw an arrow, is that told us that BE is congruent to ED. Or the definition of a midpoint. And that is the side in my angle side. The next given, angle BCA, is congruent to angle DAC. That's going to be an angle in my angle side. And then the last set of angles are going to be those vertical angles. Angle BEC is going to be congruent to angle DEA. And the reason for that is because vertical angles are congruent. And that is the second angle of my angle side. So if I combine all of these, I could state that those two triangles are congruent by angle side. Okay. From here, I can go a lot of different ways. I could state, okay, I know that side AE is congruent. Side AE is congruent to side EC by CPCPC. And then I could state, okay, and I could state that the diagonals bisect each other. I could do all sorts of things. I'm going to go a little bit different direction. I'm going to go for showing that side AD is both parallel and congruent to side BC. So I'm already halfway to the point where I can show that they're parallel. I'm basically going to be using this fact. And I'm going to say that BC is parallel to AD. Because look at that, I have alternate interior angles that are congruent. So if alternate interior angles are congruent, then the lines are parallel. And I'm really sorry my handwriting's so messy on this thing. I'm doing my best. Okay. So then I can also state, knowing that these two triangles are congruent, I also know that BC is going to be congruent to AD because of C, P, C, P, C. If I combine those two facts, well, I could say that ABCD is a parallelogram, and I'm going to use the symbol there, because one set of sides is both parallel and congruent. Okay, so what I'm going to suggest to you now is you pause the video and you take a look at the next proof and you try it on your own. Just so you know, I'm going to do this one in 2-column form, but you can do it in any style that you want. Okay, here is my finished proof. The first thing I did is I marked all the givens, and then I noticed that I have that side that's shared by two triangles, so I marked AC congruent to itself. I then went ahead and said that two triangles are congruent by angle, angle, side. Again, there's a few ways to go at this point. I'm going to show that two sets of opposite sides are congruent to one another. So I showed that BC and DA are congruent and that AB and CD are congruent by CP, CPC. And therefore we have to have a parallelogram because we have two sets of opposite sides that are congruent. So again, there's a couple different ways you could go. If you did it a different way, it doesn't mean that you're wrong, but that's just one way to do this. All right, your homework is going to be assignment C. We'll go over all the assignments when I return on Wednesday, and that's that. All right, I hope you have a great couple days.